Hello. Okay, we're just going to go over two of the problems, 10 and 12, and this would be the process that I would follow in order to solve these two proofs. So yours could be slightly different. It would need to include a lot of the same principles, but if you went in a different order, in some cases, that would be okay. Okay, so we're going to go ahead and write out our given, and that would be VZ. Segment VC is congruent to VY. And as I write these in, I'm going to mark them off. So VZ here, this whole thing, is congruent to VY. Okay. I also know that WY is congruent to XZ. So let's find those here. WY is congruent to XZ. And I'm trying to prove that VW is congruent to Vx. Okay? So knowing what you have to prove, you're kind of trying to work backwards here, okay? So think about it. Does it make sense? If this is congruent and this is congruent, those would be congruent. What are we going to have to do? Well, we're going to have to show that if I remove these two pieces, that those two pieces will be left and be congruent, okay? So in order to start, and because I know I'm going to have to remove, I'm going to go ahead and do or get rid of my congruent signs and make them equal. So VZ is equal to VY, and WY is equal to XZ, and that is by definition of congruent segments. Okay? Now, this is how I would start. So I'm going to begin by just doing my segment addition because I want to show that VW plus WY is going to equal the total segment, and same for VX plus XZ would give me the total segment as well. Okay, so that's where I'm starting. So I'm going to use the same order. So I'm going to put VW plus WY equals VY, and then I'm going to put VX plus XZ equals VZ, and that is my segment addition postulate. Okay, which we can see that's true. For my next step, okay, I know that VY and VZ are congruent. Okay, so because I know they are congruent, I'm going to go ahead and set these two equal to each other using the substitution property. So I have VW plus WY equals VX plus XZ, and that's my substitution property. And the reason I want to use my substitution property is what I'm trying to prove now is that my VW and my VX are the same. And I can do this as I show because WY and XZ are the same, that I can remove those because it's removing the same thing from both sides, okay, which I'm going to do next. So you're going to want to substitute either, it's up to you, the WY is XZ or the XZ is WY, so then I can use the subtraction property and get rid of those two, okay? So I'm going to substitute VW plus WY, that's what I'm going to choose to keep. Is Vx plus Wy. So I have substituted Xz for Wy because I can. I know they're equal. So there's my substitution. Now I'm going to subtract. So I'm going to use subtraction property. So I know if I subtract Wy and Wy from both sides, I'm going to be left with Vw equals Vx. And that is by subtraction property. Almost done here. So now I have VW equals Vx. I need to show that they are congruent. So I'm going to say VW is congruent to Vx. Pardon me, here. Put those lines above it. By definition of congruent segments. And I'm done. Okay, so think through the process you're trying to solve. How am I going to pick this apart until I get the things that I want left? Okay, so that's 10. Let's look at 12 here. So if B is the midpoint of AC, and D is the midpoint of CE, and AD is congruent to DE, then AE is going to equal 4 times AB. So, statements, reasons. Okay, let's put our given. So B is the midpoint of AC. My goodness. Okay. D is the midpoint of CE, and AB is congruent to DE. These are my given. Now, the only thing I can mark on my picture at this point is that AB, which is right here, is congruent to DE. The reason I can't mark these yet is because I haven't used my properties of showing that, by definition, that if B is the midpoint of AC, then AB would be congruent or equal to BC. We have to use that next, showing that they are equal to one another. Okay, so what I'm going to do first, since I'm going to use equal signs here, I want to get rid of this congruent sign. So that's where I'm going to start, just so I'm done with it. So now I'm going to say segment AB is equal to segment DE by definition of congruent segments. And then also from my given, I'm going to say, since B is the midpoint of AC, then AB is going to equal BC. And if D is the midpoint of CE, then I'm going to say CD equals DE. And that is just by definition of a midpoint. Okay? All right. Okay, so I'm going to include that. So now I know AB right here is congruent to BC. And I know, let's see, that CD is congruent to DE. Now we can obviously see where we're trying to go. If D is congruent to AB, then AB's has to be congruent to CD because CD is congruent to DE. We have all that to work with now. Okay, so I know they're equal. Well, think about what you're trying to say. Okay, I need to eventually have that AB, which is right here, is 4 times AE. So I need to show how all of these segments are working together. So my next step that I would do would be to use segment addition. So I know AC, because that's going to show me how I can add all these together, equals AB plus BC, and CE equals CD plus DE, and that's segment addition. Postulate. Okay, and I'm doing that because now I can, excuse me, do some replacing here. So now I know that AE here, which is my total segment, is going to be AC plus CE, right? My two other segments, and this is also segment addition. Okay, that's also segment addition. All right, now I'm going to use some substitution. I know that AC is AB plus BC, and I know that CE is CD plus DE. So let's include that whole thing now. So now AE equals AB plus BC plus CD plus DE, and that is by substitution. Okay, now if I know that, I know that AB is the same as DE, and I know DE is the same thing as CD. And I know that AB is the same as DE, and AB is the same thing as BC. So now what I can do is also by substitution, and this is all information that I have above, I have AB plus AB, and I know I can substitute AB for BC from right here, plus AB plus AB, and I can do that because AB is DE, and I know DE is the same as AC. And that's substitution. Okay, so now I'm almost done here. And then also by substitution, I'm going to simplify. So AE equals 1, 2, 3, 4, 4AB. And that's what I'm trying to get to in the end. And now I'm done. Okay? So some of these I know are more difficult. You just have to find any possible angle that you can use to work through them. Okay? Thanks for watching, and I'll see you tomorrow.